Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I will tell you the basics of control systems. Let me move on to the lecture. First, I am defining a system. We know about the system. A system is an interconnection of components which performs the operation on the input signal and it produces output signal. Here I am defining a system is one which operates on the input signal and produces output signal. This is the block diagram representation of the system. Input will be given to the system. System processes the input signal and it produces output, which is referred as C of t. C of t is nothing but the controlled variable or measured output. R of t is a reference input. This is about the system. A system may be electrical, mechanical, hydraulic, pneumatic, analog and digital systems. Then about the control system. A control system is a system which controls all the processes in the system and that force the system to give the desired response. Which controls all the processes in the system and that force the system to give the desired response. This is the definition of the control system. R of t is the reference input, C of t is the controlled variable or desired output. There are two major types of control system. First one is open loop control system and closed loop control system. Let me explain one by one. This is a block diagram representation of open loop control system. There are two blocks, controller, process. Okay, so here reference input or set point will be given to the controller. It is a collection of control elements. That control elements, it gives the manipulated input variable as the output. Okay, that controller output is nothing but the manipulated input variable. That manipulated input variable will be given to the process that processes and it forces the system to produce the desired output, which is referred as controlled output. The controller output forces the system to give the desired response or controlled output. This controlled output, it may or may not be affected, by the disturbance. Open loop control system. And then about the closed loop control system. This is a block diagram representation of closed loop control system. It consists of another block, feedback block. This feedback elements measures the controlled output and it will be fed back to the input. It will be fed back to the comparator. This comparator compares the reference input and measured output. If there is any deviation, that will be measured as E of t, errored output. That deviation is nothing but E of t. And the deviation will be again given to the controller. This controller makes the corrective action to produce the desired output. So this feedback element measures the output, measures the controlled output and it will be fed back to the comparator. That comparator compares the set point and measured output and the deviation will be given to the controller. Controller makes the corrective action and it produces the desired output. So this process will be continued until the errored output E of t becomes 0. Corrective action will be done by the controller till E of t becomes 0. So this is about the closed loop control system. This feedback elements, it measures the output and it will be fed back to the comparator and if there is any deviation, that will be given to that deviation will be given as input to the controller. That control elements makes the corrective action to produce the desired response. This is the difference between open loop and closed loop control system. And then I will tell you some of the examples of open loop control system. Some of the real-time examples of open loop control system. Lift system, electric bulb, washing machine, hand dryer. And about the electric bulb, when the electric current passes through the electric bulb, it produces light. But it is dependent on the temperature conditions. Okay, due to the external temperature conditions, that bulb may be affected. Due to the hot temperature, it may burst. It cannot make any corrective action. Okay, this electric bulb is a open loop control system. And about the hand dryer, It may, when we keep our hands in front of dryer, it will dry our hands. But it does not check whether our hands are dried or not. This is about the hand dryer. And here I am explaining about the lift system and washing machine system. See, the lift or elevator system. This is a block diagram representation of lift or elevator system. Motors and doors are the system elements. If you want to go for second floor, we will be giving, so we will be entering the button number 2. So desired floor will be the input signal. That input signal will be converted into modified input signal, which is a electric signal. That is a manipulated input variable. So here the circuit elements is the controller. Circuit elements is the controller. That a controller converts the desired flowed input to the proper electric signal. That electric signal makes the motors to activate, motors to produce the mechanical energy, and it activates the doors to open. So activation of door will be the output. Okay, so this is about the lift system. And then about the washing machine system. What are the processes done in the washing machine? Soaking, washing, rinsing and drying. So here desired time will be given as input, and that will be properly converted into the electrical signal for the 4 processes: soaking, washing, rinsing and drying for the motor. Okay, electrical signal will be given for the motor, and that processes will be done, and it gives the output as actual dryness of cloths. Actual dryness of cloths will be the output. Okay, but it does not depend on the it does not depend on cleanliness of cloths. So this is about the examples of open loop control system. We will move on to examples of closed loop control system. The good example is electric iron box. Our electric iron box. This is the block diagram of electric iron box. It consists of thermostat and heating elements and plate of iron. Thermostat and heating elements acts as a controller. And desired temperature will be given as the input. This thermostat and heating elements, it generates heat, and that generates heat for the plate of iron. So actual temperature is the output condition. This actual temperature, if the actual temperature attains the desired temperature, then the heating action will be stopped. If it does not attain the desired temperature, again through the feedback element, it is fed back to the thermostat, and it activates the heating elements to generate the heat again, to generate the temperature. Another example is voltage stabilizer. Some other example is air conditioner. Here I will tell you the advantages and drawbacks of open loop control system. What are the advantages? Open loop control system is simple and it is less expensive. Drawbacks are it cannot overcome external disturbances. Yes, no accuracy. And these drawbacks can be rectified in the closed loop control system. Advantages, it can overcome external disturbances. There will be high accuracy. And drawbacks is complex, expensive, and for the closed loop control system, that feedback element is the important one, and that should be properly designed for the system. This is about the advantages and drawbacks of open loop control system and closed loop control system. And then mathematical model of a control system. For a system through the operation, we can represent it as a block diagram. After the block diagram representation, the mathematical model of a control system is important to analyze the behavior of the system. Mathematical model of a control system is important to analyze the behavior of the system. It is an idealized representation of a system, and it is a collection of equations which describe the behavior of the system. These equations are based on the fundamental laws of physical systems. We know the types of physical systems: mechanical, electrical, pneumatic and hydraulic system. So for example, if we take the mechanical systems, the equations can be written on the basis of Newton's law of motion. For the electrical systems, the equations will be written on the basis of Kirchhoff's law of current and voltage. And there are two types of approach for modeling a system mathematically. First approach is, there are two subdivisions. One is input-output representations. Input-output representations is nothing but the relation between input and output. So for the relation between input and output, there are two models. One is differential equations. It is a time domain model equations, and transfer function model. It is a frequency domain model. And second one is state model. It is nothing but the relation between input states and output signals. So for the control system subject, we are going to study about these two representations: input output representations, state equations. Okay. The second approach for the mathematical model is experimental approach, experimental method. Apply the input signal for a system to measure the output, and then output will be compared with the experimental data. So these are two approaches for the mathematical model of a control system. This is the basics of control system. Thank you very much for watching the video. The channel name is Mani's Gate Tech Vision. This is the channel for engineering lectures. This is my mail ID. If you are having any doubts, you can mail me.